Hello viewers, welcome back to class. This is Master Builders Online Academy. Don't forget to subscribe to our YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when we uploaded. Guys, listen and listen carefully because I am super excited to have you back to class. Now, in today's class, we are going to be looking at indices. Yes, you heard me right. We are going to be looking at indices. But before then, listen carefully. Don't forget one of our policy here. So, like this video, don't forget also to avoid every unnecessary distraction. Of course, you need a maximum focus to be able to take full advantage of this tutorial class. And finally, if there be any part of this video you do not understand, please pause the video, replay it over and over again until it becomes part of you. Now listen guys, mathematics is something that is very simple, but it works with principles and laws. So once you acquaint yourself with the principles and the laws involved in any topics in mathematics, then you gain mastery over that particular topic. And that is the reason why we are here. One of the reasons why we are online is to be able to help you get the understanding of the basic principles and the rules that work in mathematics. That when you get to know these rules, you become masters in mathematics. So hope you are excited just the same way I am. Alright guys, I know many of you are set, so get your pen, get your paper, and start working with me as we progress in this class. I love you guys. Now let's get started. Now on the board we have indices. And guys, before we will be able to start solving problems on indices or know how indices questions appear, we first of all need to know what is indices. Of course guys, get this clear. Indices stems from what the word index notation. Now, index notation is a method of what shortening. And index notation is the method of shortening the product of what numbers of the same factors or numbers of the same value, numbers of the same magnitude, and numbers of the same size. So in that case, what we mean is if I have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, now this is 2 as a factor multiplying itself a number of times. So what index notation helps us to do is to pick this factor and therefore count the number of times this particular number multiply itself. So when we do this, 1, 2, 3, 4, 5, that becomes the power of this factor. That means 2 multiplies itself 5 times. So this is the index notation of these numbers multiplying itself here. Same way, if I have 5 multiplied by 5 multiplied by 5, this is exactly the same thing as 5. I will count the number of times 5 multiplies itself. And that would have given us 3 based on what we have. This is an index notation of the product of 5 in 3 places. So when a number begins to multiply itself in numbers of time consecutively, all you need to do is to pick the number and count the number of times that particular number multiply itself and turn it to become a part of this. So therefore, in other words, indices is the simplification of multiple index notation. So when you are given index notation, relationship between numbers of index notation, either by multiplication, division, or other mathematical relationship, what is indices is a plural form of index. So now guys, what should I know about index or index notation? Now if I have x, if I have something of this nature, guys, this is what we call the base. While this is called the power or the index. So you must not forget that this one here is the base and is carrying this other one as the power. So in this topic, I will be using these 2 words simultaneously. Alright? Can be using any word. So it therefore shows that the one on top is either called power or index, while the one below is called the base. So if I have to pronounce this now, this is s raised to the power of a. Now in a simple term, s raised to the power of a means s will multiply itself in a times. Now listen, also, the power of any base is what determines the number of times that particular base will multiply itself. I will come again. Now listen carefully. What determines the number of times the base multiply itself is dependent on power. So if this power here is 2, it therefore means that the base will multiply itself 2 times. Similarly, if the power is 8, it therefore means that the base will multiply itself 8 times. Are we there? In summary, the number of times the base appears is dependent on the number or the value, the magnitude, the size of the power. So if the power is 8, that means the base will multiply itself 8 times. Now if the power is 100, that means the base will multiply itself 100 times. Now if the power is 1 million, that means the base will multiply itself 1 million times. Hope you get that. Yes. Now listen carefully. So in this aspect of it, I can have this index multiply another index. I can have this index being divided by another index. And so many other relationships that can happen between 1 or 2 indexes. So why indices come in, or the simplification of indices come in, is because of the combination of 2 or more index notations. So when 2 or more index notations are combined together, there is a need for us to simplify it to its least form. And the process of simplifying this to its least form is indices. And there is no way you will be able to simplify in the complex index notation without the use of rules. And these are the rules we call the laws of indices. These are what we call the laws of indices. So guys, very quickly we are going to be examining the laws of indices. And get me clear. Without the laws of indices, you will not be able to solve indices problem effectively. Because every problem that you are going to be solving or that you will ever solve in indices are principle and law based. They are principle dependent and law dependent. So if you are far from the law, you are far from the answer. If you are far from the law, the theory, you are far from the principle, you are surely far from the answer. So the route or the way to the answer is through the laws. So very quickly, I'm going to be showing you the 7 laws of indices by their name, one after the other. So that when you see any of the indices question, you will be able to trace to this law and see the particular law that will best solve that particular question that you are given. Because every indices question are being solved with these laws of indices. So now, let's get started. Law number 1, law 1. The first law of indices is called multiplication law. Now, what is this multiplication law? This multiplication law is actually when an index notation multiplies another index notation. It therefore means that if I have x raised to power a multiplied by x raised to power b, all I need to do is to check the base. Once the base are equal, I will pick one of the base, then pick the first power. Don't forget this multiplication in indices means addition in indices. Are you there? So anytime I have multiplication in between base, it equally means that I'm going to add their power, having picked one of the equal bases. Are we there? So multiplication turns to plus, I have this. So depending on the equation you are given, you can convert from this form to this form, or from this form to this form, just depending on the type of question that you have. So this is the first law. When a particular index multiply another, you pick the base and sum up their power. Now let's get to law number 2. Law 2, we have the division law. In this division law, this is when one index divides another or is divided by another. Are you there? So if I have x raised to the power of a divided by x raised to the power of b, you also need to know now, here their base are equal. These two indexes that we have, they have equal base. So all I simply do is to pick one of the base, then take the first power. In indices, division means subtraction. So I will now subtract their powers. Of course, I can also convert from this point to this form, depending on the nature of the question. Why am I saying this? Because there are some other mathematical topics where the knowledge of indices will be required. It's not necessarily that all these theories now are applicable only in indices. No, there are some mathematical topics you'll be dealing with whereby the knowledge and the laws of indices will be required before you can provide answers to those mathematical problems. And that's the reason why you must acquaint yourself from O level to A level. The laws of indices are very, very useful when it comes to certain mathematical problems. So follow me as I give you the 7 laws, and you must ensure that before you start solving problems, you know these laws by heart. Now let's go. Then we have law number 3. Law number 3. Now for law number 3, we call this zero index law. Now don't forget that this is index. Index is power. That means zero power law. Another word for this, okay? Zero index law or zero power law. That is to say the power of the exponent is 0. Then in this case I have x raised to the power of 0. And in indices, generally in mathematics, anything raised to the power of 0. Similarly, if for instance I have 1 is equivalent to 50 raised to the power 0. 1 is equivalent to 100 raised to the power 0. 1 is equivalent to 5,000 all raised to the power 0. I can replace 1 with anything raised to the power of 0 in mathematics for me to be able to relate it to other parameters or figures that are given. Hope you are here. Now next, we have law 4. Now this law 4 is called negative power law or negative index law. Negative index law. Now this law is given by x raised to the power minus a. So in this case, now you see that the power of the index is negative. This is what this law is all about. So when I have indices question, or I have a question whereby the value I have or the base I have has a negative power, then I should apply this law. And this law simply says that you take the reciprocal of the base to the same power. This is it. So all you do is to remove this minus. This minus automatically becomes the reciprocal, which is 1 over. Pick the base, the power remains the same. All you just remove is the negative. So to remove the negative, you must introduce 1 over, then the base raised to the power of the original index. Are we there? Then law 5. Law 5, this is what we call product power law. Now, in this product power law, I can have x raised to the power a multiplied by b. Now, this is x raised to the power a or raised to power b. Is in indices by this law, power can multiply power, which shows that this is x raised to the power a times b is ab. Please, guys, if for instance I have this as x raised to the power 2, 3, it's not x raised to the power 23. You are very wrong to have x raised to the power 20. It's just that a and b cannot multiply each other to give us one result or one value. So that's why we have ab. So if I have 2 times 3, it's not 23, it's 6. So the answer to this would have given us 6. Okay? Now, if that is taken there, 10. If I have x raised to the power a, y, or raised to the power b, these 2 terms here are being affected with this power. Everything enclosed inside this bracket must be affected with this power. And understand that in indices, any base that you are given without a power has a power of 1. Indirectly, it shows that y has a power of 1. Alright? This would have given us x raised to the power a. Now, a times a will give us ab and y raised to the power b. So this power outside here have to multiply the power of the terms inside the bracket. This is what law. Now, this is what law number 4 states. Now, I'll be given as 1, 2, 3. If I over y raised to the power b or c. This is same thing as this. Everything inside this bracket is equally affected by this power c. So that's to say this would have given us s raised to power multiplied by power ac, all over power multiplied by power y b c. So this power outside the bracket affects everything inside the bracket. So this is an extension of law number 5, which is product power law. Then the sixth one, law 6. Law 6 is called the root power law. Like I said, you can use the word power, you can use the word index. Okay, so I can call this root index law or root power law. Now, in this case, I have s raised to the power 1 over a. Now, this numerator here, you know, this looks like a fraction. The numerator here must be 1 for this theorem, where this law says that this is equivalent to what? A root x. So the denominator of this fraction becomes the nth roots of the base. So the base is inside, while the denominator here is outside. So this is what? The nth roots law, or the what? The root power law, where a is greater than or equal to 2. So the least value of a here is 2. Hope I've gotten myself clear. The least power of a here is 2. Now also the last but not the least, which is the seventh law, is called the fraction index law. Now, this fraction index law is an extension of this. It's given as s raised to the power a over b. So you see that in this case, the numerator is greater than 1. Now this is equivalent to what? The denominator, the base is what you put inside. The denominator of the power is what you put outside. Then all raised to the power a, or x raised to the power a over b is the same thing as put down the base, then the numerator becomes the power of the base, while the denominator becomes the root of the base. You can put it in this form or this other form. Guys, this is what you need to know about law 7. And generally, these are what you need to know about the laws of indices. So number 1 is the multiplication law. Number 2 is the division law. Number 3 is the what? The zero index law or zero power law. Number 4 is the what? The negative power law. Number 5 is the product power law. Number 6 is the root power law. And number 7 is the fraction power law. These are the 7 laws of indices. So guys, before we start solving problems on indices, or before you start following us on lessons where we'll be looking at problems and solutions, you must ensure that you have acquainted yourself with all of these laws. They are very simple, but you need to know them. So understand that the first thing that is required from you as a student to be good with solving problems in indices are what you have on the board. So indices problems are solved effectively with the use of these 7 laws. So without these 7 laws, you will not be able to solve indices problem. Then finally, I want to quickly explain on something. Now listen carefully. S raised to the power a, which is law of division, can also be extended as s raised to the power a over s raised to the power b. This law is the same thing as this. If you believe that a divided by b is the same thing as a divided by b, so if you are given a question whereby it is arranged this way, you can still use this law whereby you pick one of the base, the first one, which is the numerator, minus the one that comes after the denominator, after the fraction. So you see it now. This is the same thing that is applicable. So this and this, they are the same. They belong to the same family. So guys, I will see you in the next lesson where we'll be looking at simplification of indices using these laws of indices. Don't forget to subscribe to this YouTube channel if you have not done so. Ensure you like this video and make your comment at the comment section how this video has added value told. Like, love you, and we want to see you in the next class. Quickly check the description below where you will find the link to the next level. See you guys. Thanks for watching.